Alright, so I got some parts in from McMaster today, and I am ready to assemble revision D of this amplifier. Now I've gotten a little bit ahead of myself with this, and I already put down the heatsink glue and already drilled and tapped, but what I'm going to do is I'm going to pull this thing apart and show you how it's all put together. So I've already unscrewed it, and oops, looks like I got a washer that fell off. No big deal. Alright, so on here you can see that I already have the mic insulation and I already have heatsink snot, or whatever you want to call it, back here. And then there goes the two screws for the RF530s. And so the two RF530s go here. I've got a little bit of heatsink grease on there. All I have done, I'll put this down carefully, is I've taken the standoffs. So these are 1¼ inch standoffs, and as you can see, I've got them screwed in just to the point where they go about 1/8 of an inch past. Each one has a washer on it to give a standoff spacing, and then I have a 256 screw right here, and I've pre-drilled this heatsink. Now this heatsink I had came with a few holes pre-drilled and tapped here, but I'm ignoring those for now. So there's 7 or so holes to drill and tap. So 4 for the 4 corners, 1 for the Anderson power pole, and then 2 for the RF530s. I then have a hole drilled into the heatsink to give this thing some clearance so that it doesn't short out to ground, because this heatsink's grounded. And this is going to be the RF power transmission. So I'm going to put the 256 screw in here like this, and I'm going to assemble the whole thing here. I'm not sure where this washer, I know where that came from. That was from a previous assembly. So all I'm going to do is I'm going to put the over the 4 studs and make sure that the 256 standoff here is clear of any metal, and I already tested this. So this is the first fundamental step of assembly. I'm going to have put in these screws, and these screws have a shoulder washer, and this shoulder washer has a ridge that goes in between the metal and the screw, so that the screw, when it tightens down, doesn't actually short to the tab of the RF530 to ground. So this going to go here, and I've already got a screw here. Alright. Okay, I'm going to give this one good tighten. Alright, and then I'm going to screw the Anderson power pole down. And when I did this, actually I should show. One thing to note about this, so this is just an Anderson power pole, and you kind of see it looks a little crufty here. That is because I actually took my soldering iron after gluing it with super glue and made sure that it's not going to do anything. I did this on both sides, so it's completely kind of bonded together. I also then drilled and tapped it, but then I realized you don't want to tap this. You actually want to have enough clearance so that the threads can slip, because otherwise, once you get this going into the heatsink, it'll actually force the two halves apart. We don't really need to add that pressure. So while it's tight enough that it's really quite close and tight, I can actually push down on this thing and it'll slip past the threads. There we go. Go all the way down to the heatsink, so that way it can slip if it needs to, because we don't care if it's threaded into that. Tighten that down reasonably. I'm going to make sure too that it still plugs in. Alright, that part's done. Now I need, just got the McMaster card delivery about half an hour ago. It's time for some standoffs. So I've got, let's see, these are 440 by half by 3/4. So sorry if I'm a little sniffly. I'm kind of dealing with a cold right now. So we'll need some of those, and then I need pair of 256 standoffs. 1 and 2. Alright, now, let's see, what are these? These are also 450s. Okay. I also am going to need a few more screws, and I have more than just a few screws loose around here, but let's see, where are they? I had another McMaster car baggie from somewhere. It's a little tiny one. Well, I'll find it here in a second. Oh, there it is. Okay. I'm also going to need a couple of 256 screws. Do 2 and 1 more. Come on. I think these are 1/4 inch 256 with a number 1 drive. Okay, so it's real simple. Now one of the things that you're going to see here now is that this dang thing is going to just sit here and spin. So what I'm going to have to do is actually hold the standoff, or the stud in place. I'm going to make sure that I have roughly the right amount of thread coming out through the bottom of the heatsink. I'm going to do that for all 4. There we go. And 1 more here. There we go. You can use a pair of pliers, or you can use, let's see if I've got, no, I just have pliers up here. Oh, well, whatever. I'm just going to tighten these buggers down now. Give them a one good reasonable tighten. Don't need to crank it down too tight, but you want a good solid connection there. Now, if I'd really done this right and I thought about it in advance, I would have actually taken this 256 standoff and attached it to the screw, and then done it beforehand. So if I ever disassemble this thing, that's what I'll do. But for now, you can actually pull up on the screw, and it'll self-tighten here. And it's getting enough grip on the other side. There. It's nice and solid. So this is actually where the RF input is here, and the RF output is this standoff, which goes up to the next level PCB. So this is the main amplifier board, and this is the low-pass filter board. There are 2 errors in revision D that you want to be aware of. One is that this power converter here for the fan is upside down. Initially, I had intended for the components to be face up, but you just have to flip the thing over. Not a big deal. The other one is error. I mean, these errors are very minor by comparison. Is that the 330 ohm resistors here were actually supposed to be 2.2 kilo ohm resistors. And the only difference is that it just draws a little bit more current, and the LEDs are a bit brighter than I had anticipated and really wanted them to be. They were blazingly bright. It's 330 ohms. So I used 2.2 kilo ohms. That's what I want to do normally. This is just going to go on, and the only thing you need to do is make sure that this header is fully lined up. Everything else lines up here. But before I put this down, I should have thought about this. No, because I didn't do it on this one. So I'm going to take this guy and put the standoff in. And this is the RF output of the low-pass filter. So the low-pass filter has its input here, goes through a low-pass filter of the appropriate choice, then through the SWR bridge, and then finally to the output. And then there's the digital control lines that go back and forth. With revision D, I added an extra signal. Actually, I added 2 signals that come from the controller board. One is a fan enable, so there's actually an enable line that goes off to the fan the buck regulator here. So that'll actually control the fan, and you can turn the fan on and off. And the other is a push-to-talk enable. So there's actually a push-to-talk enable that's coming down through this header to this board that can disable the ability of the push-to-talk line to function. That way, when you're tuning, you can run 5 watts into the amplifier through the SWR bridge to get a good reading and do a proper tuning. Before, I had to unplug the serial connection from the KX3 to the amplifier, as well as also disable the push-to-talk by unplugging that cable, because the amplifier is talking back to the KX3 and was looking to see if it was greater than the recommended input power for the amplifier, because if you try and transmit with 50 watts with the low-pass filter, with the tuner going, you'll blow the finals out of it. So it didn't have a way to shut it down. So now I've got the standoff on up here. Gotta make sure that gets connected. Oh, goddamn cold. Alright. And looks like I might have something binding here. It looks like maybe this thing. So there's the... No, that's fine. Yeah, I see what's going on. There is a filter, or an inductor, right here, and I need to push that over just a little bit. There we go. Okay. I'm hoping this is focusing for you. I have no clue. There we go. It all fits together nicely now. Put 4 standoffs on. Okay, so now I've got the 256 screw, low-pass filter board on, and I've put the 4 standoffs on, and I've also got the 5th standoff on here as well for the power transmission. So the last thing is to put the ATU board on. Just got to make sure that the 10th inch header lines up. Nothing too fancy. At this point too, I'd probably actually should say that I probably would want to put the fan on and trim the cord and have it be the appropriate length. But for right now, I'm leaving the fan off. I can put that on at any time, really. Now, this whole system is really easy to take apart and put back together again, even in the field. So what I'm going to do is push this bugger together. Get a 256 screw. And I've also got my, actually before I put my 256 screw in, I am going to also put my 440, at least 2 of them, just to make sure that everything is lined up properly. Here I'll just do all 3 of them. Well, I'll do 4. And the only reason I'm putting these things, it's not actually to hold the board down, but it's just to hold the alignment correctly, so that when I put in this 256 screw, that I can tighten them down just a little bit. Make sure I don't over tighten them. And I don't have to worry about the alignment of the circuit board, because the alignment can go a little bit wonky. There's really nothing holding it down over here other than whatever screws go in here. So this can, in theory, wiggle around a little bit. So just to prevent that, I put those screws in while I tighten this down, but then take it out. You can use 1/4-inch screws or 3/4-inch screws, doesn't really matter. So this system is actually now fully assembled and functional. If you wanted to run this without the case on, I would recommend putting at least a 1/4-inch 440 screw right here, just so that you can ensure that you have a good grounding path for the RF signal path. But I'm going to actually put the case on. So the case is very similar to the RevD case. Let's see, here's the back end. The main differences you can see is I added some text lettering in here to actually say here's what's going on, and to take into account that the BNC connector is different. I think with this particular design I'm going to need to move this up just a little bit because it has a tendency to bind with this. So let's go ahead and put it together. So this is going to slip on and get it about right. And it's a little bit stiff because I think it's binding with the BNC connector, so I just have to kind of get it to push past whatever it's binding. There we go. Yeah, it's binding on the BNC connector is what it's binding on, but not too big a deal. And yeah, that's on there nice and solid now. The front lid. Almost have to lever it in a little bit because these little tabs are kind of almost, interfering almost. There we go. So you just have to kind of lever it in just a little bit here. And then this little tab slides right across the top of the relays. Kind of designed it that way. And just make sure you don't crush your buttons here. Once you get it here, you're going to have a little bit of a gap, and you just got to push everything past. Have it print so the tabs lock in together. So now the tabs aren't going to let this flex or anything, because when this gets connected, this side here really flexes in, whereas this has those tabs here which prevent that. So it can't push outwards and it can't really push inwards unless it does so over here as well. So there we go. Just need to do the rubber feet now. I got one rubber foot. These are a little bit different from the previous rubber feet that I had. The last ones I had, these are harder rubber, but they didn't have a metal insert. These actually have a piece of metal in them, a metal washer for durability, and they're softer rubber, so they have a little more squishiness to them. Just standard, otherwise generic rubber bumper feet off of McMaster. There we go. Hiding. One more screw. And yeah. One last screw. Yeah, these are definitely softer than these guys. Much harder rubber on the old ones. And it has a tendency to crack. I think those rubber feet were probably old from some previous project. There we go. So that's a Revision D amplifier. Let's plug it in. I've got a plug-in cable here. I've already updated the most recent firmware onto the circuit board. So the big changes with this, as I said before, is the BNC adapter change, the standoffs that do the RF power transmission, and the ability for the controller circuit to turn off the push-to-talk. So the MCU in here can actually disable the push-to-talk line coming from the KX3. So if you accidentally transmit when this thing is in a different mode, or you've somehow disabled it, or it's got a high SWR, this system can say, no more, I'm going to turn you off and not let you operate anymore. So power button, there's a little bit of lettering in here, so you can say band up, band down. This is the same functionality as before. Tuning now in the firmware will actually send a command to the KX3 to say, hey, go into a 3-watt mode, disable the amplifier in here and put it into pass-through mode, so that the automatic tuner in here can be running just off the power from the KX3. That way you're not trying to tune it up while you're running 50 watts. If you try and do that, you're going to blow up the finals in this thing. I've done it. Don't do it. It's bad. It instantly pops. Actually, it doesn't really blow up the finals anymore now that I have a fuse. RevB, I added the fuse in here. RevC was mostly just the standoffs and cleanups, but it was RevD in which I added a fan control, so you can turn the fan on and off, and I also added the push-to-talk disable or push-to-talk enable, however you want to look at it, so that it can disable the amplifier. And it disables both the bias and the actual TR relay. So it still does the same thing tuning, so you can tell it to tune, but now it just sends a serial command over to the KX3 to actually disable or enable the transmit and disable the push to talk. And that's really the major changes. Other than that, everything's basically the same. I can take this Rev A amplifier. Again, pardon my cold. plug it in. So obviously I don't have the fan on the RevD amplifier yet, but I'm not too worried about that. But these both literally have the same functionality. And then I can tune. Same tuning algorithm, nothing too much more fancy, just a little bit more lipstick, and that's pretty much it. So that's revision D. I'm looking forward to putting up a few operating videos of it up and running, because hopefully this is the last version of this particular amplifier that I'll be building. And I'm looking forward to using it actually at 50 watts. So anyway, thanks for watching, and I'll see you in the next operating video.